Give me a thumbs up. All right.
Thank you, Diane. Tonight's presentation, Maui Astronomy. Maui is a beautiful Hawaiian island that we all know about, with astronomy clubs, public astronomy events, and famous professional observatories. Tonight's presentation, our presenter will discuss all of the above, including the types of research being done there. Now a little bit about our presenter. His interest in astronomy has been since his childhood, and he still is a proud owner of his first cardboard telescope. He's been a Detroit area resident his entire life. He retired at the end of 2001, and his hobbies in addition to astronomy are his grandchildren, digital photography, and operating the largest website about Maui, Hawaii. He is our past president and vice president of this organization. His knowledge of astronomy was learned from members of the Warren Astronomical Society and the 7 other astronomy clubs in Michigan and Maui that he belongs to. By joining these, he learned how to use his telescope and learn about astronomy. Now he just comes to socialize and eat whatever snacks are left. And maybe something on the horizon when I hear him when he's joined 7 other astronomy clubs, so he has a total of 8. Could it be possible that he could join 50 astronomy clubs in 50 states? That remains to be seen.
Give it a go.
Our featured presenter tonight, Mr. Jon Blum.
Most of you know I live on Maui in the winter and belong to astronomy clubs there as well as here. So I get to see a lot of what goes on in Maui astronomy and decided to learn more about it for this presentation. I want to mention that I'm sorry if I cough a couple times during this. I'm having a reaction to a medication, not a cold, but a strange reaction to a blood pressure medicine that causes coughing. So tonight we're going to talk about Maui astronomy. Last September, Jim Shedlowski gave us a great presentation about Arizona astronomy, and that's when I decided to do this talk about Maui astronomy. But unlike Jim, I'm not going to be singing at the end of my presentation.
Good.
The Hawaiian Islands are a string of about 140 islands stretching over about 1,500 miles in the middle of the North Pacific Ocean. Only the 7 largest islands have people living on them, and only the 6 largest islands can be visited by tourists. So here you see the red line in the upper picture shows you the string of the islands. Okay. The islands were all formed by volcanoes erupting from the ocean floor over millions of years, while the tectonic plate that the islands are on moved westward 3 inches per year over a stationary hotspot of erupting lava. The western 95% of the islands are the oldest, and they're all eroded into tiny seamounts, atolls, which are ring-shaped coral reefs, and underwater hills. The eastern 5% of the islands are the large ones that are inhabited. The 2 newest islands, and hence the 2 largest islands, are the Big Island of Hawaii and the island of Maui. They're the largest because they've had the least time to erode. The Big Island of Hawaii is still growing, enlarged each day by fresh lava pouring into the ocean on its southeast edge. Here in the picture you see the islands in order of size, with the Big Island in the bottom right of the picture, where you see lava still erupting. Here's a satellite view of the islands, and you can get a general idea that the islands are largest on the right side, the eastern end, and they get smaller as you go to the west, and then much tinier ones continue up in that long string that I showed you in the other picture. Maui is the 2nd largest, but bear in mind Maui also used to be connected to Molokai, Lanai, Kaho'olawe. So this used to be one island, and so this made it similar in size to what the Big Island of Hawaii is today. And then this eroded to separate this into islands, and you can see Maui's going to erode eventually into 2 separate islands here in the middle. The Big Island of Hawaii on the eastern end of the chain is by far the largest and the highest. It's only 400,000 years old. It's about 4,000 square miles, has a population of 185,000 people, and most important for astronomy, its highest elevation on the mountain called Mauna Kea, which means White Mountain, is 13,796 feet. Maui is the second most eastern, the second newest, and the second largest island. Its large eastern half is just 800,000 years old, and its small western half is 1.3 million years old. It's about 727 square miles, has a population of 144,000 people, and most important for astronomy, its highest elevation on the mountain called Haleakala, House of the Sun, is 10,023 feet. Oahu, 3 million years old, is the third largest island at 597 square miles, has the largest population at 953,000 people, but with an elevation of only 4,000 feet, it's not appealing for astronomy observatories. In the next few slides, I'm going to use these three terms interchangeably. And there's often a mistake, people who haven't been to Hawaii, confusing the Big Island with the island of Oahu. Oahu is where the most people are. It's where Pearl Harbor and Honolulu are, so it's the most famous island. And people often call it the Big Island, but that's incorrect. The Big Island's name is Hawaii. So Hawaii Island is the largest of the Hawaiian Islands. It's not the island with the largest population, which is Oahu, that has the city of Honolulu. The Big Island is the nickname for Hawaii Island. It's used to try to avoid confusion caused by the fact that the name of Hawaii Island is the same as the name of the state of Hawaii. Mauna Kea is the tallest volcano mountain on the Big Island of Hawaii, and so this is the location of the professional observatories on that island. Mauna Kea means White Mountain, so named because it often has snow on the top. I'm going to discuss some of the Big Island observatories before I go on to those on the island of Maui. We'll also cover some brief info about public astronomy on the Big Island of Hawaii and on Oahu before moving on to Maui. The interesting thing in this picture taken on the Big Island is that in the foreground you see the observatories on the Big Island that we're going to talk about. But in the background, 100 miles away, you see Haleakala on the island of Maui. So the reverse is when I'm standing on Haleakala for astronomy observing at the top of Maui at 10,000 feet. I can see 100 miles away across the ocean and see the Big Island of Hawaii with a snow-capped top on Mauna Kea. And with binoculars, you can easily see the white dots of these observatories on the Big Island. Mauna Kea on the Big Island of Hawaii has several famous telescopes, including the Keck 1 and 2, each 10 meters, the Subaru, 8.3 meters, the Gemini North, 8.1 meters, the University of Hawaii, 2.2 meters, NASA Infrared, 3 meters, Canada, France, Hawaii, 3.6 meters, United Kingdom Infrared, 10 meters, and then they have sub-millimeter scopes and the very long baseline array, or a radio scope. A whole talk could be done on each one of those, but I'll only have time for a brief summary of each of those. The largest and most famous telescopes on the Big Island of Hawaii are the Keck 1 and 2. Each of these telescopes weighs 300 tons, so I did not pass my test of a telescope I could put in my car or bring to set up at the WAS. You've heard my talk about how my main decision in what telescope to buy was which one I could lift up. Each of the Kecks has a 10-meter mirror composed of 36 hexagonal segments. Here you can see a cutaway view. In 1999, the Keck 2 became the first large telescope to use adaptive optics. Initially, adaptive optics relied on the light of a star that was both bright and close to the target celestial object. But there are only enough bright stars to allow adaptive optics correction in about 1% of the sky. In response, astronomers developed laser guide star adaptive optics in 2004, using a laser to excite sodium atoms that sit in an atmospheric layer 60 miles above Earth. Exciting the atoms in the sodium layers creates an artificial star for measuring atmospheric distortions, in which the adaptive optics uses to produce sharp images of celestial objects positioned anywhere in the sky. The Keck now claims to produce more detailed images than the Hubble Space Telescope. In the cutaway view, you notice the hexagonal mirrors down at the base of the Keck. The Subaru is another telescope on the Big Island. This is an 8.2 meter scope owned by the National Astronomical Observatory of Japan. As you know, Subaru is the Japanese name for the open star cluster that we call the Pleiades. Several cameras and spectrographs can be mounted at Subaru telescope's 4 focal points for observations in visible and infrared wavelengths. Research done on the Subaru includes studies of interstellar dust, dark matter distribution, and exoplanets. Another observatory on the island of Hawaii is the Gemini North. Its twin, the Gemini South, is in Chile. The purpose of these two locations is to have access to the entire sky in both optical and infrared from the northern and southern hemisphere. These two 8.1 meter telescopes are operated by a partnership of 5 countries, including the United States, Canada, Brazil, Argentina, and Chile. Any astronomer in these countries can apply for time on Gemini, which is allocated in proportion to each partner's financial stake. The Gemini Planet Imager is an instrument that allows researchers to directly image and analyze exoplanets that are a millionth as bright as the host star around which they orbit. Gemini supports research in the solar system, exoplanets, star formation and evolution, the structure and dynamics of galaxies, supermassive black holes, distant quasars, and the structure of the universe on the largest scales. The University of Hawaii has a 2.2 meter telescope on Mauna Kea. It was the first large telescope built on this mountain in 1970 and demonstrated how useful this location would be for telescopes added in later years. This 2.2 meter scope discovered the Kuiper Belt in 1990 by being the first to detect objects other than Pluto in this part of the solar system. The NASA Infrared Telescope Facility is a 3 meter telescope on the Big Island, customized for use in infrared astronomy. It was first built to support the Voyager missions and is now the USA National Facility for Infrared Astronomy. At least 50% of the observing time is devoted to planetary science. Canada, France, Hawaii 3.6 meter telescope's recent research includes a study showing that an object must have a mass of at least 70 Jupiters in order to start hydrogen fusion. If it has less mass, the star does not ignite and becomes a brown dwarf instead. Another recent study produced a composite image of dark matter connecting 2 galaxies. The United Kingdom Infrared 10 meter telescope is the second largest dedicated infrared telescope in the world, but it's set to be removed as part of an agreement to take down 3 of the old telescopes on Mauna Kea if and when the new 30 meter telescope is built there. We'll be talking about that in a moment. The Caltech submillimeter 10.4 meter telescope is also being removed as part of the plan for construction of the new 30 meter. The James Clerk Maxwell 15 meter telescope is the largest single dish telescope that operates in submillimeter wavelengths. It's used to study the solar system, interstellar dust and gas, and star formation in other galaxies. The submillimeter array consists of 8 6-meter radio telescopes arranged as an interferometer for submillimeter wavelength observations. It studies dust and gas at temperatures only a few tens of kelvins above absolute zero. Objects with such temperatures typically emit the bulk of their radiation at wavelengths between a few hundred micrometers and a few millimeters, which is the wavelength range in which the SMA can observe. Commonly observed classes of objects include star-forming molecular clouds in our own and other galaxies, highly redshifted galaxies, evolved stars, and the galactic center. The Very Long Baseline Array is a system of 10 radio telescopes, which are operated remotely from their Array Operations Center located in Socorro, New Mexico, as part of the Long Baseline Observatory. These 10 radio antennas work together as an array that forms the longest system in the world that uses very long baseline interferometry. The longest baseline available in this interferometer is about 5,351 miles. So you can see these are actually scattered in locations. My laser pointer doesn't want to point, but scattered in locations around this side of the globe. The new 30 meter telescope is proposed to be built on Mauna Kea, but is presently being blocked by a long court fight by native Hawaiian groups who are opposed to further development on the mountain. It may end up being built on the Canary Islands instead of Hawaii if these protest groups succeed in blocking it from the Big Island. You can't drive up to the top of the Big Island of Hawaii after dark because the road is unpaved and can be covered with ice or snow. But there is an organized public observing party every night in the Onizuka Center for International Astronomy Visitor Information Station at the 9,300 foot level. The road is paved and ice-free to that point. Back down near sea level on the Big Island of Hawaii is the Astronomy Center of Hawaii, an astronomy and culture education center located in Hilo. It features exhibits and shows dealing with Hawaiian culture and history, astronomy, and the overlap between the two. Moving now to the island of Oahu, the Bishop Museum has a planetarium, but there's no professional observatories on Oahu because I mentioned the elevation of the highest point is only about 4,000 feet above sea level. The Hawaii Astronomical Society is a large astronomy club on the island of Oahu. Each month they have 3 public star parties, 1 members-only dark sky star party, 1 indoor lecture meeting at the Bishop Planetarium, a board meeting on the University of Hawaii campus, and multiple outreach events for schools and other groups. The club's Hawaiian name, Hui Kulani, means group watching the heavens. You notice that the members are wearing shorts and sandals for their observing night. This club seems to have even more activities than we do. So now as we're moving on to the island of Maui, my favorite place, you can see that Maui is composed of 2 halves. Haleakala is the newer, larger, higher eastern half of Maui. And the west half is just called the West Maui Mountains. And there's a narrow valley between the two. Maui is sometimes called the Valley Island. Maui, like all the Hawaiian islands, is slowly eroding and eventually will be divided into 2 islands, and eventually, like the other islands further west, will be eroded all the way down into the ocean. Maui is at a latitude of 21 degrees north, a little south of Mexico City's latitude of 23 degrees north. Detroit's at 42 degrees north latitude. Here you can see the location of Maui, roughly where Mexico City is. So everything in the north sky is lower on Maui than in Detroit. This picture is taken at a new club that I've told you about called the Farmington Community Observers. Farmington Community Stargazers. They meet at Heritage Park in Farmington Hills, and this club's purpose is only for public outreach. But what I want to show you in this picture is you can see the Big Dipper and the pointer stars of the Big Dipper pointing to the North Star behind me in the picture. And I've drawn lines to show you that the longest vertical blue line shows you that Polaris, the North Star, is 42 degrees above the horizon. Wherever you are on Earth, if you're in the northern hemisphere, Polaris is the number of degrees up in the sky that your latitude is. So I brought a green line halfway up that blue line to show you that on Maui, Polaris is only at 21 degrees. So Polaris is half as high on Maui as it is here in Michigan. The reverse is true in the south sky. So Sagittarius, which at its highest is about 20 degrees above the horizon here in Detroit, is about 41 degrees above the horizon in Maui. That's why we can see the Southern Cross, Alpha Centauri, and the Omega Centauri globular cluster. Bill Beers and I had to get up at 4 a.m. this past winter because that's what time these objects are best visible in the winter months in Maui. And you know you feel real bad about the fact that we had to get up at that hour to go see Omega Centauri and the Southern Cross. I'm not an astrophotographer, but this is just my point-and-shoot camera. I sit on top of the roof of my car taking a picture of the Southern Cross, and then the same picture is on the left and the right. I just labeled it on the right side. The Maui Astronomy Club is a club for the public rather than for member observing. There are a few members with telescopes, and we set up on a different beach park each month and invite Maui residents and visitors to look through our telescopes. We usually don't get girls in bikinis coming to look at the Warren Club. The Maui Astronomy Club has no indoor meetings or lectures, only outdoor public observing events. Here's the Maui Astronomy Club being set up on a black sand beach. Sometimes it's so cold on winter nights in Maui that I have to wear long pants. And I'm planning to write to you guys to tell you how bad it is there. The club was started by and run by Becky Sidney. She's the most enthusiastic amateur astronomer I've ever met. Here you can see her talking to Jonathan and Diane. And on the right you see her giving her usual excited talk to the public. Here's Becky with Dale Parton, with John Lyons, and with Tim and Leon from the Ford Club. Sometimes Becky sets up her telescope near the big resort hotels, and people who come to Maui for other reasons can discover the wonders of Maui astronomy. So one night we were set up behind a hotel, and some couple had just had their wedding in the hotel, saw the telescope, and the bride came out and had her first view through a telescope. Another club on Maui is the Haleakala Amateur Astronomers. They're the opposite of the Maui Astronomy Club, since the Haleakala Astronomers only has observing for club members and invited guests, who are all serious amateur astronomers. The public's not allowed to come to their special observing site on the top of Haleakala Volcano. They have a concrete pad with piers, a warm room with red lighting, and 2 telescopes, one in a dome and one in a roll-off roof building. The only downsides are that it's cold up there, and we have to drive up a 38-mile mountain road with 29 switchbacks. It takes an hour to get the start of that road from my condo, plus an hour to go up that winding road. Here's the concrete pad with some piers they have set up, and here's the warm room, here's their telescope in the dome. This is the warm room, we got red lights in here, you can go in there and warm up. The observing site for that club is located beside the professional observatories on the top of Haleakala in a restricted area called Science City. Observing at the top of Haleakala begins with a beautiful sunset. We're generally above the clouds, so you're seeing the sunset down into the clouds. The Haleakala Amateur Astronomers were started by and is run by Robert Kowski on the left in this photo. He's a professional photographer who also works part-time as an assistant in some of the professional observatories in Haleakala.
Hey.
Rob recently completed this analemma photo at the top of Haleakala. Here's his explanation. I use an automated camera to do a single exposure of the sun at 5:10 p.m. every day for a year. I select files that came from Thursday, the most productive day, or from Wednesday or Friday as alternates, if Thursday was poor weather. The files were then composited along with a foreground image producing the final product. I managed to get 50 of the 52 weeks required, the 2 missing images from cloudy, wet weeks. Amazing to have the patience to spend a year making this photograph. Bill Beers and I presented Robert Kowski with a Warren Club logo plaque listing WASP members who have observed with the Haleakala Amateur Astronomers. This plaque still hangs on the wall in the club's observing site warm room. I got the idea for the plaque from Bob McFarland, who gave the Haleakala Club a plaque from the Ford Club the year before. So both plaques are still hanging in the clubhouse. Rob's an excellent astrophotographer. He's taken some great photos of the zodiacal light, which can be a source of annoying light pollution on the top of Haleakala, another source of sympathy that you'll give me when I have to spend the winter in Maui.
Yeah.
So here you see the zodiacal light, this triangle of light in the west after sunset, that's lighting up dust in the plane of the solar system. Here's some people that have joined me observing up on top of Haleakala with the club. On the upper left is Bob Noya, former editor of Sky and Telescope. In the upper right is Tim and Leon from the Ford Club. In the lower left is John Lyons from Seven Ponds, and he's here tonight. In the lower right is Chuck Jones from the Ford Club. Jonathan and Diane are on the upper left. Bill Beers on the upper right, Dale Parton on the lower left, and Doug Bauer from the Ford Club on the lower right. A third astronomy club, you can never have too many astronomy clubs. The third astronomy club on Maui is one that I started for people staying in the condo building where Rosie and I live in the winter. Here I set it up on the pool deck. I found that if I tell people in the condo that I'm going to set up my telescope 10 minutes away, uphill and away from the condo lights, most of them can't be bothered driving 10 minutes to go. But if I set it up around the pool, even though we've got light pollution around there, more people are likely to show up and take a look through the telescope. In 2010, when there was a total eclipse of the moon, I demonstrated to people in the condo parking lot how a lunar eclipse works, with Rosie holding a flashlight representing the sun, and me positioning people to represent the moon and the earth. This is the condo building called Mahana that we live in the winter, so I call my little club the Mahana Astronomy Club. On the roof of the Hyatt Regency, Maui's largest hotel, every night they have astronomy viewing for small groups of tourists for 1 hour. They They charge $30 per person.
Whoa.
Well, we Astronomy Club members are happy to show the public astronomy for free.
Holy Christ. There's a piece of the action for that.
I think people might be more likely to come if we charge $30 than if we tell them it's free. A private company called Maui Astronomy Tours has a 2-hour astronomy observing in the public area at the top of Haleakala for $100 a person. Again, we Astronomy Club are glad to do that for nothing. Before we move from amateur to professional astronomy on Maui, let me mention the Hawaiian demigod Maui, for which the island is named. The mythology states that Maui lassoed the sun to slow its progress across the sky, so his mother's tapa-cloth garments would have more time to dry in the sun. Most people outside of Hawaii never heard of the demigod Maui until last year's Disney movie called Moana. And in that movie, if you saw it, the two main characters are Moana and the demigod Maui. I'll leave it to you to figure out which is which. Another old Hawaiian legend is that Maui uses fish hook to fish up the Hawaiian Islands from the ocean. So what's the astronomy connection to that? Maui's fish hook, that plays a prominent part in the movie and in that legend, is a Hawaiian constellation that we call the Scorpion, that you could see could just as well be a fish hook. The ancient Polynesians used celestial navigation to explore the whole Pacific Ocean. They came from the South Pacific and discovered the Hawaiian Islands only in the 13th century. Now we're going to switch from talking about amateur astronomy on Maui to talking about professional astronomy in the observatories on the top of Haleakala. They're here because at 10,000 feet, they're above about 30% of the atmosphere and usually above the clouds. An advantage of Haleakala on Maui over Mauna Kea on the Big Island is that access is easier to Haleakala with a paved road all the way to the top and no snow. We'll start by zooming in from the Hawaiian Islands to the observatory site. So here we have the 7 largest Hawaiian islands, the islands that people can be on, with Maui over here. Here we've zoomed in on Maui. We have the West Maui Mountains, the small half. We have Haleakala, the large half of Maui. We have the crater in the center. At the top of Haleakala is a huge caldera, often called a crater. A caldera is a large depression that forms following an evacuation of a magma chamber. When large volumes of magma erupt over a short time period, structural support for the crust above the magma chamber is lost. The ground surface then collapses downward into the partially empty magma chamber, leaving a massive depression at the surface. The island of Manhattan would fit inside of the Haleakala crater. It's about 7 miles across, and you can stand on the edge looking across the crater or hike down into the crater. Here's a close-up view of the crater from a satellite view, and you can't really tell much, but this is all the crater. And you can stand around here on the edge and look down into the crater, or hike down into here, hike across the crater, and hike up the other side. I haven't done this. And there's a few cabins in the crater. The cabins are free, but there's so much demand for the cabins that they're on a lottery system. And some friends of ours submitted to the lottery and did get a chance to stay in a crater, in a cabin down there. The husband said they won the lottery, and the wife said they lost the lottery and had to stay in the cabin. So here's a video that I will try to play. These don't always work. You know, when we try to get videos to play from PowerPoint. Okay, it's working. So this is just to give you an idea of what it's like up on top of Haleakala. There's a parking lot. You're above the clouds, or above most of the clouds, looking down on the clouds. I want to show this video for a couple minutes because I think it gives you a better feel for what it's like up there than just the still pictures. Here we have, of course, the professional observatories. Here's the new solar telescope being constructed. We'll be talking about that in a few minutes. We'll be talking about each of these professional observatories. Airports have a surveillance spot that we'll be talking about up there. Here's just the end of the switchback road. So you come up a lot of these switchbacks to get up to the top. It's all volcanic rock up here. Very sharp, rough edges of lava, stones every place. The whole island, of course, is made out of lava. Again, the solar telescope that's under construction. It's further advanced than that now. You'll see some pictures of it the way it looks today. Here's the separate road that goes over to the professional observatories. Here's what it's like just walking along the top of the lava ridge, looking out to the crater, looking out to the clouds. You feel like you're sort of walking on top of the clouds when you're out there. You're closer to the clouds than you'd be on an airplane, so it's a whole different feeling. Instead of just a tour bus coming up. Here's one of the public observing sites. You can take the drive all the way up to this parking lot, and then you have to walk up the last few steps, and it's you get out of breath, it's at 10,000 feet. So even though you only have to walk up about 25, 30 steps to the top, so you can get out of breath doing it. Tourists taking selfies. When you're looking out into the crater, sometimes there's clouds down in the crater. Sometimes the crater is completely clear. Rosie and I go up there a couple times each winter, so we've seen the crater full of clouds, seen the crater completely empty of clouds and everything in between. Watch clouds roll in and out of the crater. A popular thing there is to go up for sunrise. When you come up at sunrise, of course, it's pitch dark when you get up there. You see all the beautiful stars. And then you watch the sun, and the sun appears to rise out of the crater because the position that you go up to watch sunrise, you're looking to the east across the crater, and so you see the sun appearing to come up out of the crater. That's what makes sunrise sort of more interesting to watch than sunset. When you watch sunset from up on the top, you watch the sunset down into the clouds, which is interesting, but not quite as beautiful as seeing the sun rise up out of the crater. Here's a nice view of the crater, where you'd be standing on the edge watching the crater, and if it was sunrise, you'd be seeing the sun come up out of that position.
John, do you know how deep the caldera is?
3,000 feet. So it's a strenuous walk down and up. The rangers tell you if you want to go for a partial hike, this is a quail. If you want to go for a partial hike, you should time it, because it's going to take you double the time to come up as it took you to go down. So if you want a 3-hour hike, you should only walk down for 1 hour. It's also cooler down in the crater than it is up at the top.
That's interesting.
Which island is this?
I'm sorry?
Which island?
No.
This is Maui.
That bird you were showing, John, is it a flightless bird with the nose fly?
Those can fly.
Because they are flightless birds, flying.
Oh. You're just some of the professional observatories again. Okay. Now we're looking down at the a close-up view, satellite view zoomed in of all the professional observatories on top of Haleakala on the island of Maui. And here's the same photo with these labeled. I needed help from Rob Benkowski, who is the head of the Haleakala Amateur Astronomers, for me to figure out from the serial view which one is which. And right here is where the club's observing site is, where the club has our warm room and a concrete pad. You might wonder how a club could possibly afford such a thing. And the answer is somebody abandoned some old building up there, and somebody knew somebody who knew somebody who knew there was a club that would be interested, and said, as long as nobody's using that building, why don't you guys just come up there and use it? That was about 10 or 12 years ago, and nobody's kicked us out yet, so we just keep on going there. Here's another view of all these professional observatories. We're going to talk about each one of them separately. The professional observatories on top of Haleakala on the island of Maui. Pan-STARRS is the Panoramic Survey Telescope and Rapid Response System. Pan-STARRS is probably the best known telescope on top of Haleakala because comets it discovers are named after it, such as this example, comet Pan-STARRS C2011L4. But the main goal of Pan-STARRS is to find near-Earth asteroids and comets that might pose a risk to Earth. This is a quote from Bob Trembley's t-shirt. Asteroids are nature's way of asking, how's that space program coming along? This chart shows a count of discovered near-Earth asteroids as of the start of 2017. It shows the one discovered by Pan-STARRS in purple. Pan-STARRS started operations in 2009, so you can see that after 2009, the purple line gets bigger and bigger as more and more of the near-Earth asteroids get discovered by pan-stars. Pan-stars consist of two telescopes, PS1 and PS2. PS1 went online in 2008. It has a 3-degree field of view and the world's largest digital camera with 1.4 billion pixels in an area of 40 centimeters square. Each image is 2 gigabytes. Exposure times are 30 to 60 seconds, recording objects down to magnitude 22. It takes images continuously and collects 2 terabytes of data every night. It images 6,000 square degrees of sky every night. The total sky is 41,000 square degrees, of which 30,000 square degrees can be seen from Hawaii. Avoiding times when the moon is bright, it images the entire sky 4 times per month. It compares old and new images to find anything that has moved or changed in brightness. The PS2 only recently came online with the same size telescope. It points at the same area of sky as PS1, and the images from the 2 telescopes are stacked to improve the signal-to-noise ratio and eliminate detector artifacts. Of course, the idea of comparing last month's pictures to this month's pictures is to look at something that's moved or changed. That would be an asteroid maybe headed for us. In 2014, Pan-STARRS released a composite image made of 500,000 images taken over 4 years. It shows the entire part of the sky that's visible from Hawaii, which is 75% of the sky. ATLAS is the Asteroid Terrestrial Impact Last Alert System. ATLAS is a telescope on Maui that became operational in 2015, and one on the Big Island that opened in 2017. 6 more are planned in other parts of the world. Each has a 100 megapixel camera. The last alert part of the name refers to the fact that ATLAS will find smaller asteroids much too late for potential deflection. But the days or weeks of warning it gives would be enough to evacuate a target area. It intends to provide a 1-week warning for a 45-meter diameter asteroid and a 3-week warning for a 120-meter one. It will observe the whole sky twice per night, whereas Pan-STARRS takes a week to complete 1 sweep of the sky in a deep but narrow survey. ATLAS will search the sky on a closer and wider path to help identify the smaller asteroids that hit Earth much more frequently. FOX is my personal favorite professional telescope on Haleakala because it's right next to the club's observing site, and right after sunset, we get a show when we watch the clamshell open, turning it from this, the closed clamshell, to this, the open clamshell. And here, if I can get this video to work, is a video. I've sped it up 8 times because neither you or I have the patience to watch it at normal speed. So this is 8 times speed. I'm hand-holding the camera, so sorry for the shakiness. This is the telescope opening up at sunset, and in a moment you'll see Dale Carter dressed up for a cold night observing over on the right. And at the end
Can we get one of those for Stargate?
I'm sorry?
Can we get one of those
Yes.
for Stargate?
Yes, definitely.
No, then they'll charge us to use the place.
How big of a scope is that?
I don't know offhand, but it'll be coming up in one of the slides in a moment.
Thank you.
It's used for education. Notice the sun setting in the background. You can see the 8 times normal speed sunset as the sun goes down into the This is the Coast Guard communications station that I zoomed in at the end. Oh, the answer, Jim, is 2 meters. I didn't take this picture. This is a great picture. It looks like the Milky Way is coming out of the Fox telescope. At 2 meters, the Fox is the largest telescope in the world that's dedicated to education. It's been operating since 2003. Its purpose is to get teachers and students to engage in research-based science education by providing them free access to this robotic telescope and a programmer to help them run it remotely. It's part of a network of 8 telescopes in various locations around the world dedicated to the same purpose. The others are 0.4 to 1 meter telescopes. They're all part of the Las Cambras Observatory Global Telescope Network. Teachers and students can apply for free remote time on this telescope for their research project at foxtelescope.com. The AEOS is the Advanced Electro-Optical System, the largest observatory building on Haleakala, and you can see the public summit in the background. This observatory is a cylinder with reflective sides, so it's the easiest building to see from down at the base of the volcano because it brightly reflects the sunlight. When we're down on the sea level on Maui, if we look up at the top of Haleakala, we can see light reflecting off the observatories up there, especially off this bright, shiny one. The center of the top opens is shown at the left, and the telescope pops out, is shown above. Here's what's inside the big silver cylinder. We could get you one of these for Stargate too. A 3.6 meter telescope with the highest order adaptive optics in the world, meaning the largest number, 941, correcting elements, actuators, to correct for atmospheric distortion. The AEOS is owned by the Department of Defense, who I'm sure would be glad to buy us one, and operated by the Air Force and the University of Hawaii. It's the United States' largest optical telescope designed for tracking satellites. It can also track ballistic missiles and can slew at 20 degrees per second. It also does high-resolution visible and infrared spectroscopy. AEOS can be used simultaneously by multiple groups or institutions because its light can be channeled through a series of mirrors to 7 independent rooms below the telescope. MSSS is the Maui Space Surveillance Site. It's initially opened in 1965 and now has 3 facilities in one building. One is AMOS, the Air Force Maui Optical Station, which conducts research and development of new and evolving electro-optical sensors. Second is the Maui Optical Tracking and Identification Facility, which consists of 2 1.2 meter telescopes on a common mount used for long-wave infrared and photometric data collection, shown in the photo on the right. The third is ground-based electro-optical deep space surveillance. So here's GEO-DSS, the last one I mentioned. There are 3 ground-based electro-optical deep space surveillance sites spaced around the world in Maui, New Mexico, and Diego Garcia in the Indian Ocean. They're all operated from Peterson Air Force Base in Colorado. The photo shows the one at Haleakala and Maui, which has been operating since 1983. Also in the same building in this photo are AMOS, the Air Force Maui Optical Station, and MOTIF, the Maui Optical Tracking and Identification Facility. Combined, these 3 are called the Maui Space Surveillance Site. The GEO-DSS system is for tracking man-made objects that are more than 3,000 miles up. There are over 9,000 such distant objects, including geostationary communication satellites at 22,000 miles. There are 23,000 man-made objects orbiting the Earth, including active weather and GPS satellites, and inactive space junk, such as rocket bodies. The oldest object tracked is Vanguard 1, launched in 1958 and still in orbit. Object crossing the International Space Station orbit within 20 miles caused this facility to notify the ISS to be ordered to adjust its orbit to avoid collision. Each GEO-DSS site has 3 telescopes. Each is a 40-inch scope with a 2-degree field of view. They're operated from Edwards Air Force Base in California. I was surprised to learn that the GEO-DSS facility in Diego Garcia in the Indian Ocean is at sea level and not on a mountain. I don't know why that is.
There's no mountain.
Good job.
The United States Coast Guard Communication Network is in these small buildings. They have tall antennas that we saw in the sunset photos. Oh, wonderful. Notice from my computer. Sure, yes, I'm sure. The Zodiacal Light Observatory houses 2 instruments. The Scatter-Free Observatory for Limit Active Regions and Coronae telescope is a 0.5 meter off-axis reflecting coronagraph that is used to study the sun's corona. The day-night seeing monitor makes telescope-independent observations of perturbations in the atmosphere above Haleakala. I don't know why they don't just wait for the eclipse and watch the corona then. The neutron monitor station is adjacent to the club site. It's presently an empty building that a couple club members sometimes use to sleep in so they don't have to drive down the mountain in the dark when they're tired after hours of observing. The building used to house a cosmic ray neutron monitor station from 1991 to 2007. Current plans are to use the building for planets, which I'll discuss in a second. Planets is the polarized light and atmospheres of nearby extraterrestrial systems. Planets will be the world's highest contrast optical telescope. The University of Hawaii Institute for Astronomy will use this to study circumstellar environments and extrasolar planetary atmospheres. It will be a 2-meter off-axis scope with low scattered light, adaptive optics, coronagraph, polarimetry, and spectropolarimetry. Polarimetry is the measurement of rotation of light and pass through various compounds. The telescope is not yet built, so this is only a small scale model in the photo. Planets will have a stellar coronagraph to block out the blinding glare from a star. While most coronagraphs have been used to create an artificial solar eclipse to see the corona of our sun, the planet's stellar coronagraph can be used to see planets around other stars, the disks that form them, or the tenuous outer atmospheres of solar system planets like Mercury. These exoplanets' outer atmospheres and disks can be millions to billions times fainter than the glare around them, making a telescope capable of containing and removing the glare allows for the detection and study of the light from the faint source. TLRS is a transportable laser ranging system. It's a NASA device that measures the distance to the moon by bouncing a laser off mirrors left by the Apollo astronauts and timing the round trip of the light. It also measures the distance to artificial satellites to determine their precise orbits. It's been here since 2005. Sometimes I see the bright green laser firing from here, and I'm observing at the site of the Haleakala amateur astronomers. This whole TLRS system fits in a trailer 22 by 8 by 8 feet, above the 3 blue underlines in the bottom of the photo. The Mies Solar Observatory has multiple instruments attached to a single equatorial support. There are a white light imager, imaging vector magnetograph, high-resolution spectrograph, and imaging polarimeter. It has been in operation since 1963. One project at Mies is to study solar flares and how they affect the Earth. Hale means house, A is of, Ka is the, and La is sun. So the house of the sun, Haleakala, is the perfect place for the Daniel K. Inouye Solar Telescope, now under construction. These photos were taken from 2013 through 2016, so you can see the various stages of construction of this huge new solar telescope being built on top of Haleakala on Maui. The construction has made a mess for us to get around on our way to the Haleakala Club, causing another reason for you to give me sympathy about all the trouble I have there on Maui. This is a 2017 photo showing that the outside of this facility is now completed, but the inside is not yet done. Here's a cutaway view of what it's going to be on the inside of this building. When completed in 2019, the Daniel Inouye Solar Telescope will be the world's largest solar telescope. It will have a 4-meter primary mirror. It has an off-axis clear aperture design and adaptive optics. Its high-resolution images will show features on the sun as small as 0.03 arcseconds or 20 miles diameter. It was funded by a large group of universities and other institutions, coordinated by the National Science Foundation, and to be run by the National Solar Observatory and the Institute for Astronomy of the University of Hawaii. DKIST plans to study the nature of solar magnetism, how that magnetism controls the sun, and how we can model and predict the sun's changing outputs that affect the Earth. The DKIST will take images every 3 seconds to resolve rapidly evolving structures on the sun's surface and lower atmosphere in wavelengths from near ultraviolet to deep infrared. Daniel Inouye, after whom the telescope was named, was a Hawaii congressman and senator for 50 years. He died in 2012. So now you've heard about all the observatories that are labeled in this photo on the top of Haleakala. And now you've looked down into the crater, but take my word for it, it looks a lot better in person. Here's a view of a few of the professional observatories taken from our club observing site. I'm not much for astrophotography, but here's a picture of Venus and Mercury that I took a couple of years ago from the club observing site. And now it's time for you to plan your trip to Maui.
Lousy.
See in the dark, who's back there?
Hey, no totem.
Jonathan.
We're not at Macbeth Halbert anymore, right?
Yeah.
Yeah.
So, how far below the actual summit is the professional telescope observing area?
About 100 feet. As Jonathan points out, the very top of the mountain is where you can go up and look into the crater and you can set up your telescope for public observing, is a small area, not big enough to build observatories. So the observatories are built 100 feet lower down than the very summit. Jim?
John, have you heard the 30-meter telescope and the controversy?
Yes.
Has there been any talk about locating it on Haleakala?
Well, I don't think so. I think there's not space for something that big on Haleakala.
Was that right? I just wondered. Because it's 10,000 feet.
And we have our own
That's still higher than the
Yeah.
Chilean.
We have our protesters on Haleakala too. Just last week, as they were bringing up truckloads of parts for the solar telescope, about 80 protesters laid across the street and tied themselves together to block the convoy because they don't want anything built up there. And police had to pull them apart. And got complaints about police brutality pulling them apart so the convoy could get through to pick up parts. So anytime you're building anything, it's not just telescope. When you build a hotel in Hawaii, you have the same problem. The Ritz-Carlton started building, I think, 12, 14 years ago, and they found a few bones in the area they were building, so that was suddenly declared a sacred site, and they had to relocate the hotel higher up the hill, so the Ritz isn't on the beach where they originally planned to build it. So there's always native protesters about any construction in Hawaii. John?
Yeah, John, I didn't see any pictures of the gate with all the locks hanging on it.
There's the area where the club meets is a restricted area in this professional area, and as John recalls, we had to fiddle around with some complicated lock mechanism to open the gate to get in there. And that's even more fun in the dark when you're coming back.
Joe had a hand.
Joe?
John, with not much vegetation to minimize like erosion, is there a problem with dust and with the instruments? I mean, I know there's got to be high winds up there.
Yeah, there are high winds up there. That's a great question. I don't know the answer to how much problem they have with dust up there. It's certainly an all rocky environment. There's plenty of dust and plenty of wind. Bill?
When we were up there, it was pretty cold. Can you tell us the difference in the temperatures between down below and up on the top?
It's about 25 degrees colder on the summit than it is on the beach. So in the evening, it dips down to a chilly 70 or so on the beach, which makes it down to about 45 on the summit. And when the wind's blowing, that's real cold, especially if you're standing around by the telescope. That's probably the lowest in the middle of the night. I think when Bill and I were up there, it was about in the 50s, in the low 50s, wasn't it?
It was pretty chilly, but it was windy, which really made it cold.
Oh, yeah.
What's the largest amateur scope up there that you can use that's more or less there permanently?
The club has a 12-inch that's up there permanently, but there's one of the members of the club that's got a 16 that he brings up there sometimes.
Does the Inouye solar telescope, is that basically going to be what replaces the McMahon solar telescope at Kit Peak?
I don't know.
Decommissioning.
Are they decommissioning the one at Kit Peak? I didn't know that.
It replaces it as the largest solar telescope.
It'll still be operational.
But
The Kit Peak one's still going to operate?
It'll still operational.
Is it? I thought it got defunded.
They were talking about that, but
Might
it would be very expensive to replace.
Here's a non-astronomical question regarding Hawaii. How much local reverence is there
to the goddess Pele, who is responsible for everything there, supposedly.
That's the whole point.
There's a lot of legends about Pele, who's the volcano goddess, and the most common one is that you shouldn't steal any of her rocks, and if you bring home any of the volcanic rocks from Hawaii, you'll have bad luck. And plenty of people have written stories about how they had bad luck after they brought home rocks, and the Park Service there regularly gets in the mail rocks that people are mailing back to the national park because they had bad luck and they brought home the rock, and they regret it and they apologize and mail back the rocks. I have a large website about Maui, and I get a lot of interesting questions about Maui. And once somebody wrote to me asking if they could mail me some rocks, but I told them to send it to the Park Service.
That's good of you.
Marty?
I found out that after you've already missed an eclipse, it's okay to take a rock home with you.
Well, I'll talk to Madame Pele, the Hawaiian volcano goddess, about that.
So related to that, don't go watch this eclipse with Marty.
Of course, it's illegal to take anything out of a national park.
I did that
And
once.
Haleakala is a national park, so if you're going to steal a rock and invite the wrath of the volcano goddess, at least don't take it from the national park. Take it from somewhere. The whole island's made out of volcanoes, so there's plenty of rocks. Okay.
All right. All right, as is traditional, we'll migrate from here to the Red Coat Tavern on Woodward Avenue, just north of 13 Mile Road.